Hello everyone, welcome back to the channel. This video is in continuation with the previous video. If you haven't watched that video, you can check the link which is available in the description box. In that video, I had discussed the K-maps. We have seen that how can we make the K-map for 2 variable, 3 variable or 4 variable problem. In K-maps, we have the cells corresponding to each combination of the input, and these cells are labeled using the gray code since we need that there should be only variation in one of the variable when we are moving from one cell to another cell. We have also seen that we can make the groups of the adjacent zeros or ones depending upon whether we are given with the minterms or the max terms respectively. They can be combined in group of 2, 4 or 8 resulting in a pair, quad or octet. Now in this video we will see that how can we write the expression corresponding to each combination. Now these Boolean expressions can be given in the form of SOP or POS, and accordingly how to write the expression that varies. This video will particularly focus on the expressions for sum of products form. The product of sums form will be discussed in the coming videos. Let's take an example over here for the 4 variable problem, that if we are given with few minterms, let's say y is function of 4 variables and it is given as summation m 3, 4, 7, 11, 12 and 15. So what we need to do, we need to write all these, we need to place all these minterms in the K map. So firstly we have 3, 4, 7, 11, 12 and 15. So once we place all the minterms in the K map, then we need to start the grouping of ones. So when we are doing the grouping of ones, our target is always to look for the octet. Is there any octet possible in this case? No. So next preference is that we need to look for the quad. So do we have any quad? Yes. We can make the quad of these 4 adjacent ones which are there in the form of a column. Now corresponding to this column, we need to check each row correspondingly and we need to see whether any variable is remaining same or they are going to change when we are moving from the first cell to the last cell. So if we move from here to here, we see that b is changing from 0 to 1, so v is not there in the expression. When we move from here to here, then we see that a is changing from 0 to 1, so a is also not there in the expression. So a and b, they will get eliminated, while when we move on to this side from the column side, c and d both are remaining same. So we have a quad made up of 3, 7, 11 and 15. Corresponding to this, we need to write the expression, and what's there in the expression? Expression is CD. Now why it is CD? Because on this side the variable c and d, they are remaining constant, their value is 1 1, so they are written in their true form. Then we need to look for the other option, that what are the other combinations. So we are left with just 2 ones. They are also in the adjacent cells, which will result in a pair. So we have a pair made up of 4 and 12. Now when we see on the row side, which variable is remaining same? Variable b. B is having value 1, so b is written as it is. From the column side, c and d both are remaining same. Since their values are 0 0, so c is written as c complement and d is written as d complement. And our final expression, which is in the form of sum of products, is cd plus b c complement c complement. Now what we see, each pair over here, each group over here that has resulted in one product term, like one quad has given one product term, pair has given another product term, and then they are combined together in the form of sum. This is how we write the expression. Now let's take some examples over here, that how we can have the problems which we can solve using K-map. First one is minimize the Boolean function y using K-map. Also draw the logic diagram corresponding to minimized expression. Means firstly we need to minimize the function and then we need to draw the logic diagram as well using different gates. Now what's the Boolean function given? Y ABC equal to summation m 0, 2, 4, 6 and 7. Now it's a 3 variable problem, so we need to use a 3 variable K-map in which we will have 2 rows and 4 columns. On the row side we start with the MSB, so we have A and B and C are on the column side. Now you can have value 0 or 1. BC can have 0 0, 0 1, 1 1, then 1 0. When A is 0, it's written as A complement 1 A, B is 0 B complement, C is 0 C complement. So here we have B complement C, B C, B C complement. Now this one is corresponding to minterm 0, 1, 3, 2, 4, 5, 7 and 6. Now next step is we need to place all the minterms which are given in the expression. We have 0, 2, 4, 6 and 7. So after placing the minterms, what we need to do? We need to make the combinations of the minterms. So again our first priority is that we need to look for whether there is any octet possible or not. Since again we don't have any octet, so we need to look for the quad. So is there any quad possible? Yes, quad is possible if we fold like this. If we fold the K-map from these two sides, then it will result in a quad of 0, 2, 4 and 6. Then we are left with a 1 which is minterm 7. Now this minterm 7 we need to combine it with minterm 6. Now this minterm 6 it is used twice, but there is no issue. We can use one minterm as many times as possible if there is any single one left in its adjacent cell. So we have a pair of 6 and 7. Now we need to write the expression corresponding to pair and corresponding to the quad. So if we look for the quad first, from the row side A is changing from 0 to 1, so A is not there in the expression. Here we have B 0, C 0, but if we look in this column we have B is 1 and C is 0. So B is also changing, it will also get eliminated. So what we are left with? C. Since the value of C in both the columns is 0, so we need to write C complement. So the expression corresponding to the quad is only C complement. And when we look for the pair, from the row side, variable A is remaining same for both the cells. A has value 1, so it is written in its true form. Then we move on to the column side. On column side, when we see B is 1 for both the columns, so it is same, while C is changing from 1 to 0. So C is not there in the expression, we will have only B. So finally expression Y, it will be equal to AB plus C complement. Now corresponding to this minimized expression, we need to draw the logic diagram. So what we can see that we need a NOT gate over here in order to obtain the C complement, an AND gate for A dot B implementation, and one OR gate is also required. So let's make the logic diagram. So we have three inputs A, B, and C. A and B, there are the inputs to the AND gate, which will, from where we will get the expression AB. Then we need a NOT gate here to obtain C complement. Now these two, they will act as input to the OR gate, and finally we have the output Y. This is how we can get the final output Y by three input variables. Now let's take one more example. The second problem says obtain the minimal expression for the function y a b c d equal to summation m 0 2 4 6 8 9 12. Now this is a four variable problem, so we need to use the four variable k map. Now let's make a four variable k map first. So in four variable k map we have four rows and four columns. Again, on the row side we start from the MSB. So we have A and B on this side and C and D on this side. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Corresponding to this, it's A complement, B complement, A complement B, AB, AB complement, C complement, D complement, C complement D, CD, C, D complement. This one is minterm 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15 and 14. Now next is we need to place all the given minterms in the cells corresponding to them. So we have minterm 0, 2, 4, 6, 8, 9 and 12. Now once we place all the minterms, we need to start the grouping of all the minterms. Let's see how many groups are possible in this case. We have a quad possible of 0, 4, 8 and 12. So this is one quad which is possible. Corresponding to this, we need to write the expression. So when we write the expression from the row side, variable A and B, they are changing when we are moving from first cell to second, second to third and so on row wise. I'm not talking about the cell designation which is mentioned over here. I'm just saying 1, 2, 3, 4 like this. So it's varying. So A and B, they are not there in the expression, while the C and D, they are remaining same and their values are 0 0. So it's written as C complement D complement. Now we need to look for the other possibilities. Now what is the next possibility? One can say that they can make the pair of 2 and 6. But that is not true, because if we fold like this, then what we have? We have a again quad possible of 0, 2, 4 and 6, because we need to look for all the possibilities, whether there is any possibility of the octet first, and if octet is not there, whether there is any possibility of quad. Our target is not to look for the pairs, we always need to look for the octets. If not, then look for the quad. Last option is the pair. So we have the second quad. This is first quad. Quad 2 of 0, 2, 4 and 6. For this quad, if we check the row labels, A is remaining 0. So A is same while B is changing. So A 0 means A complement. And if we check column wise, C is changing from 0 to 1. C is not there in the expression. D is remaining 0 in both the cases. So it's written as D complement. Then what we are left with? We have one min term 9. So instead of keeping it a single one, it is possible to combine this min term with the eighth min term to result in a pair, pair of 8 and 9. So when we write the pair of 8 and 9, since it's the same row, so A and B, they are remaining same. A is 1, so A is written as it is, B is 0, B complement. And we'll look for the column side. C is remaining same, its value is 0, so it's written as C complement. So what's the final expression of Y? Y is equals to C complement D complement plus A complement D complement plus A B complement C complement. So in this case we have three individual terms. All the three individual terms, they are the product terms, and then they have combined together to result in an expression which is in the form of SOP. Let's take one more example and then we will look for the POS expressions. So next one is obtain the minimized expression for the given Boolean expression. What's given in Boolean expression? Y, A, B, C, D is equals to summation M 0, 3, 6, 11, 12, 13, 14 and 15. So again it's a 4 variable problem. Let's make the 4 variable K map first. A, B, C, D 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is min term 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. C complement D complement C complement D C D C D complement A complement B complement A complement B A B C D complement. Now next is we need to place all the given minterms in the K map. Now the given minterms are 0, 3, 6, 11, 12, 13, 14, 15. Now we need to look for what are the different possibilities of the minterm combinations. The first one, which is very easier to see, that is a quad of 12, 13, 14 and 15. Now since these minterms are spread across all the columns, so C and D, they are going to change when we move from this here to here. So C and D, they are not there in the expression, while from this side what we have? A and B. A is 1, B is 1, so expression is AB. Then what options we have? we can combine 6 with 14 to make a pair of 6 and 14. Also, we have 11th minterm over here. Now, one can say that they can make the pair of 11 and 15. This could be possible if we don't have this minterm 3 over here. Since minterm 3 is there, so what we need to do, we need to make the pair of 3 and 11, because if we fold the K map like this from this side, then we will have 3 and 11 in the adjacent cells. So since this combination is possible, so we don't need to use this 15, because if we make the pair of 15 and 11, that will be a redundant term, and we don't want any redundant pairs over here. So we have the second pair 2 of 3 and 11. Now let's see what else left. Now we are left with a single one, since there is no combination possible. So we have a single one. For that we need to write the expression, a single one, which is minterm 0. So corresponding to minterm 0 expression is a complement, b complement, c complement, d complement. Remember, this is what we have covered in the video which was there on the introduction of minterms and the max terms. So link of the same is also available in the video. If you haven't watched that, you can look in that in order to get the idea how that expression is written. Then we have the pair of 6 and 14. Now for 6 and 14, if we check row labels, variable b is remaining same. So b is there. Since its value is 1, so it's there in the true form. From column side, we have the labels c, d complement. Since both the variables are same, so they are remaining in the expression. For the pair of 3 and 11, from row side, which variable is remaining same? Variable b. So this one is a b complement. So variable b is remaining same. Variable b, its value is 0, so it's b complement. From the column labels, we have cd. So what's the final expression? Final expression of y is a complement, b complement, c complement, d plus ab plus b c d complement plus b complement c d. So this is a final minimized expression using the K-map. I hope with this you will be able to understand that how to solve the Boolean expression using K-maps. If you feel this video is helpful, do like the video and share it with your friends. In the next video, I will discuss that how can we write the expressions in the form of POS using the K-maps. Thanks for watching the video.